Okay, so today's video is on lesson 4.5a. Lesson 4.5 is split into two lessons. The first part is going to focus on adding, subtracting, and multiplying, and then the second part is going to be on division and real world situations. So I think the most difficult part of today is just kind of getting used to all of the definitions and talking about domain. The basics of adding, subtracting, and multiplying, you have already done all of this stuff in class in Algebra 2. So a lot of it is review, but some of it is new. So what I want to do is I want to just kind of introduce you to the actual notation of it. So what does it look like? If they want you to add two functions, it's going to look like this right here. So if you've got your highlighter, this is what it's going to look like typically on your benchmark or your end of course or on a test. But what it really means is this. Okay, I think the second one makes more sense. I can't tell you why they write it that way, but they do. Same thing with subtraction. It's going to look like f minus g of x. And that just means, subtract f of g minus g of x. So it's pretty straightforward. The first notation is typically what you're going to see, but this is what it means. And those are the three that we're going to talk about today. On your notes, I just kind of want you to make a little note that this was typically end of course, which is your big state test at the end of the year. And then this one is what you will use on Desmos if you have the ability to use Desmos. So just over to the right, we have two different functions. We have 5x, it's linear, and then we have another linear function right here, which is x plus 2. And what they're going to do is they're going to ask you to do different things with both of those functions. So if you add them together, you're going to wind up with 6x plus 2. If you subtract them, and this is what I was mentioning earlier, if you're subtracting a group of items, make sure that you subtract x and subtract 2. We do have an example on that later. And then if you're going to multiply them, you're either going to have to use the distributive property or you might even have to use the box method. So that's pretty straightforward. We're going to talk about domain when I get to it, but we're going to skip over this part for a second and we're going to just go straight to adding. So if you do have your two highlighters, we're going to highlight the f function and we're going to highlight the g of x function. These are both square root functions, okay? So in this problem right here, it says find f plus g of x. That just means to add. So that's the notation that it looks like. I'm going to go ahead and write the notation that makes a little bit more sense. We're going to add f of x to g of x. Then what we're going to do is we're going to substitute. So f of x is going to now be 3 square root of x. So I'm substituting the notation f of x with the actual function. And then g of x is negative 10 square root of x. So the next question you need to ask yourself, am I able to actually combine these two things? So earlier in chapter 4, you learned that if you have the same root, and these are both square roots, and if you have the same radicand, and the radicand is x in both of these, you can combine them. So you're just going to kind of do in your head 3 minus 10, and 3 minus 10 would be negative 7 square root of x. So that is the result when you add the f function to the g function. Okay, so look directly underneath it. What it's doing is it's saying, I want you to evaluate what you get after you add your f and your g function. So what I'm going to do is I'm going to substitute f plus g with what I got earlier. So I know that I'm going to use negative 7 square root of x. Now I just want you to think, what do you think we're going to do with that for? What do you think it's asking you to do? So sometimes people think that that means to multiply by 4. But typically it's written as an x, right? So they replace the x with a 4. So all they're wanting you to do is they're wanting you to substitute 4. So all you have to do, and you can do this on your calculator or you can do it in your head, whichever one you want to do. You do have to replace x with 4. And that's going to be negative 7 times 2, which is negative 14. So what we're going to do is we're going to skip to subtracting, and we're going to go back and we're going to revisit like domain. So if I wanted to subtract these two, this is f of x. Let's not mark it out. And this is g of x. Ooh, that's a big one. These are cubic equations. So they have that like up coaster, roller coaster kind of pattern to it. So I want to subtract them because it says f minus g. So I'm going to subtract. And I'm going to go over here and I'm going to write something that makes more sense. I'm going to say f of x minus g of x. So if you see f minus g, it just means take the f of x and subtract g of x. Now, replace f of x with the actual function. So I'm going to write 3x to the third minus 2x squared plus 5. Now remember, I have to subtract the whole entire g of x function. So I'm going to have to put that in parentheses. I'm going to do all of that, but it's all one group. So I have x to the third minus 3x squared plus 4x minus 2. Everything in the parentheses will need to change its sign because I am subtracting. So, and this is something that you can do in your head, but for your notes, I do want to show my work. So I'm going to write it down plus negative x to the third. So everything in parentheses needs to have an opposite sign. Positive 3x squared, negative 4x, plus 2. So we're going to add our like terms. I have these two. That's going to add up to 2x to the third. And then I've got these two. That's going to be positive x squared. And I don't have anything that matches negative 4x. And then I'm going to finish it out by adding 5 and 2. And I get 7. So my final result after subtracting is this. So this part right here where it says to evaluate, we're going to substitute negative 2. Whenever you substitute, make sure that you use parentheses. So I'm going to set it up. And I'm going to plug in negative 2 where there is an x. Okay, so just very carefully type that in your calculator, and I'm going to pause the video, or you pause the video, type it in, and see if you get it right. So I got 3. Okay, and let's tackle multiplying now. So we're going to multiply this quadratic times this square root. So you need to be able to rearrange it, like rewrite it to make this work, okay? So I'm going to multiply f of x times g of x, which means x squared times the square root of x. Now listen, if this is more than one term, you're going to have to distribute. Okay, so if it asks you to multiply like a binomial times a binomial, you'll have to do the box method. This is just 2 terms, super simple, okay? All right, now, there's no way I can combine it the way that they are written. What do you know about the square root of x? There should be an alternative way to write that. How do you write it? Instead of the square root of x, we write x to the power of 1/2, because the denominator is going to be the root. So I'm going to rewrite it as x squared times x to the power of 1/2. Here's where your exponent rules come into play. So if you have the same variable and you're multiplying them, what is your rule for your exponents? What do you do to them? You add them together. So on your calculator, if you add 2 plus 1/2, you get 5/2. So while this is technically correct, it's going to be likely that your final result should be x to the power of 5/2. Okay, so I think you know by now what this one's asking you to do. It's not asking you to multiply by 9, it's asking you to substitute the 9 for x, right? So I'm going to, instead of writing x, I'm going to put 9 to the power of 5/2. And you can simply type it in your calculator if you want to. I would actually suggest doing that because that number is kind of big. And when you plug it in, you get 243. You may want to check that real quick and see if you get it right. Okay, so now for probably the most complex part of it, we're going to talk about the domain. For you to be able to understand the domain of adding functions, subtracting functions, multiplying, dividing, all that, you have to understand the domain of each parent graph, okay? So what I'm going to do is I'm going to just kind of remind you of what each parent graph looks like, okay? So first of all, I have y equals x. That is linear. What is the domain of a linear function? Do I have anything limited to the left or to the right? Nothing's limited. So the domain's going to be all real numbers, okay? Now, what if I made it x squared? That's going to look like a smiley face, right? It's a parabola. Do I have any limitations? I do not. It always goes forever to the left and to the right. So this is all real numbers. If I made it cubic, that's going to wind up being an up coaster. Still, no limitations. There's one other that we talked about in class, and that was the absolute value of x. That looks like a V. Is it limited left to the right? No, it's not. None of those are limited. The only one that's been limited in Algebra 2 so far is y equals the square root of x, right? Because where does this graph start? It has a starting point at 0, 0. Yeah, and it kind of shoots off in that direction. So our domain is limited to 0 and everything greater than that. Now you got to keep that in mind, okay? So let's slide back over here. When you find the domain of the sum, the difference, the product, or the quotient, what you have to do is you've got to include all the values that are in common with both f and g. Now I'm going to show you a little demonstration using my colors, okay? So let's say I shade a portion that is in yellow, okay? And then I decide to shade a portion in blue. And I have a little bit of overlap, okay? So I have a little bit of overlap. Now what happens to the overlap? What can you see? It turns green, right? Okay. So let's say that you actually have a function and that domain is the whole thing. It's all real numbers, okay? And then you all of a sudden have something that has a limited domain, like a square root. And that limited domain is everything on this side. Where is the domain that they have in common? It's only that part on the right, isn't it? Okay, so what you're going to do is you're just basically going to use that limited domain as your total domain. And it doesn't matter if you're adding, subtracting, multiplying, or dividing. So just kind of keep that in mind. Okay, so let's think about what do these graphs look like? Those are square root graphs, right? So the domain of this one is going to be, let's write this over here. So 3 squared of x. The domain is x greater than or equal to 0. If you use Desmos and you graph it, you should be able to see it starts at 0 and everything greater than 0 is your domain. The other one is reflected, but the domain is still everything greater than or equal to 0. Nothing's changing. So if they're exactly the same, then they have everything in common, right? So if you added them together, then your final domain is just still going to be greater than or equal to 0 because they're all in common. Okay, second one. These are cubic equations. Cubic equations are not limited. So you have something that has all real numbers And the second one is also all real numbers. So it's basically the whole thing in common. So it's going to wind up being all real numbers again. So your domain, I don't care if you add them, subtract them, multiply, or divide them, they're going to wind up being all real numbers because that's what's in common. When you're multiplying these two fractions, same thing, but this first one looks like that because it's a parabola. It's x squared. The second one looks like this. The second one is limited. So you're only going to have what's in common where it's limited. So even if that first one has all real numbers, the second one is limited. So you're going to use the limited x is greater than or equal to 0 because that's the only section that they have in common with each other. So here's what I want you to do. I want you to take a few minutes. I want you to try to work out 1, 2, and 3. And just pause the video. And then when you're ready to check it, go ahead and unpause and we'll see if you get it right. Okay, so let's check number 1. If you add them together, you wind up with negative 3 squared of x. The domain of both of those are x is greater than or equal to 0. And if you plug in 16, you wind up with negative 12. Number 2 is a little bit longer because you have to subtract everything in this function. So what that means is that you're going to have to rewrite it, and you're going to have to subtract 3x to the third plus 5x squared minus 6x plus 9. And if you didn't do that, your final result's going to be wrong. So you have to get this part first. Once you get that part correct, if you plug in the negative 1, you wind up with 37. And the reason why the domain is all real numbers is because both are cubics, and cubics have no limitations. So their domains start out as all real, and that's what they'll have in common. The last one, you have to do a little bit of a trick when you multiply them together. You have to rewrite the square root of x as x to the power of 1/2. And then you have to add your exponents together. So 3 plus 1/2 is 7 over 2. Your domain is limited on the g of x function, which limits your final answer domain. So your domain is going to be x is greater than or equal to 0. And if you plug in a 4, you wind up with 128. I do want to warn you, your Big Ideas textbook, instead of saying x is greater than or equal to 0, for some reason it feels the need to say all non-real numbers. No, it doesn't say that. It says all non-negative numbers. That's what it says. So all non-negative numbers is the same thing as x is greater than or equal to 0. I don't know why it does that, but it does. All right, so what I did is I flipped it back over, and we're going to look at the graphs now. So y'all see that blue graph right here? That blue graph looks like it's some version of a quadratic. It's not exactly x squared. It's been transformed in some way. And then the red one looks like it's linear, which is x, okay? And it's been transformed, but I'm not really worried about it. I just kind of have like a generic idea, okay? So what it wants us to do is it wants us to add the graphs together. So this one says f of x plus g of x. Let me tell you how to do that. So what we're going to do is we're going to pick a couple of points on the same x value, okay? So let's say x is 0. So I have 0, 0 here. You can go ahead and put that in your notes, okay? And then this one is 0, negative 1. See how they both have the same x value? So what we do when we add functions or add graphs, we add the y coordinates together because the x value is going to be the same, okay? So 0 plus negative 1 gives you negative 1. So when you add these two together, the new point is going to be 0, negative 1. Now let's look over here at our choices. Do I have 0, negative 1 here? Nope. Is it here? Nope. What about here? Yes. And then what about here? No. So that one's actually pretty quick. So I know that it's going to be C. Now you can do that with any point for your x value, and I'll prove it to you really quickly. So let's say I have a point here That is 2, 2. And then I have a point here at 2, 1. If I add the y coordinates together, I get 2 plus 1 is 3. So the new y coordinate is going to be 3. Look over here. 2, 3. See, it matches. So when you add the quadratic to a linear, it's going to stay quadratic. But visually, you add the y coordinates together. So let's see if we can do the subtraction one real quick. So I'm going to use the same 2 points, but this time I'm going to subtract it. So what is 0 minus negative 1? 0 minus negative 1 is positive 1, isn't it? So look and see if you can find one that has a point at 0, 1. 0, 1. Yes. No. We already picked that one. No. So it has to be this one. It absolutely has to be that one right there. So this one's going to be C. And this one is going to be A. I'll show you one more time. 2, right here, this 2 minus this 1, it should give you a new coordinate at 2, 1. There it is. 2, 1. So it's absolutely for sure going to be A. Now I'm going to show you a different way to find the next one. This one is multiplication. Okay, so remember I said that this one is quadratic and the other one is linear. What do you typically get when you multiply x squared times x? What power do you get? What do you get when you multiply x squared times x? Don't you get x to the power 3? Do you see any of them that look like a cubic function? Which one? D. That's it. That's all you got to do. So you can do it in lots and lots of different ways. So if that one's D, then that means the other one is B, and we will talk about that in the next lesson.